Good morning, Justin. This is Curtis Herrman, and I'm going to make you a video about the tire hammer. I'm going to answer some of the questions you asked and a few that you didn't ask. I'll probably post this up to YouTube and use it for future reference. So this is the hub that I use. It's just a standard 5 on 4.5 pattern from a 3,500 pound axle. This is a Dexter hub. I prefer the Dexter hubs to the import hubs. They're just a lot beefier, stronger, and there's a couple of things that I'll show you in a little bit that they just work better for. But you can see the strength and the gusseting there, how thick that the ears are. They're easily notable by the star pattern on them instead of just being a continuous round circle. But the others will work fine as well. That's just my preference. So when we mount the tire to the tire hammer, we do it in an odd manner. We mount it backwards. And so the hub is going to go in here. And there's a space there. I call this area of the rim the bowl. I don't know a better way to refer to it. And the hub doesn't go all the way down. So you see it touches right along here in these areas. And so what we do there is we just take this to the belt sander or use a flat disc on an angle grinder, and we're just going to take a bevel right across here on all 5 of those stars. Doesn't take very much at all, and that will fit down. The next problem is this surface is not flat. It doesn't go well towards mating. In the plans it talks about using some flat washers, stacking them up, and then bolting it up, then indicating it, spinning it, do a spin test, and then adjust as needed. I make this hub spacer. It's a consistent thickness. It works well. It lays in here, raises you above this protrusion, and these areas of the hub spacer sit on top of the flared part of that, and just gives you a good flat surface now for the hub to fit in. Goes in there and all is well. So that's that side of it. Now that I'm going to move on, I'm going to turn the tire over, and I'm going to move on to the crank plate. So the crank plate consists of the crank circle. We currently cut them with a water jet. They're cut very accurately. The inside diameter is purposely cut to fit tight on that hub so that it'll be hub centric. And these holes here are cut so that a 1/2 inch bolt fits really tight in there. You're going to put a 1/2 inch, 3 inch long grade 5 bolt in here, and you're going to weld it on the back side so that it won't fall out later. And so here's one that is partially done. The crank circle have been welded to the 6 inch schedule 40 pipe. We do weld this seam around here, but it's more cosmetic than anything. We're going to weld up a good fillet weld on the inside, and you have your bolts that are welded in. So that's how that goes. Here is a finished crank plate. So we have the actual crank plate itself right there, the 1 inch thick piece. It's already drilled for the bolt, crank bolster right here. So we put the 1 inch grade 5 bolt through here. We put the crank bolster on, weld it around. It's there's some instructions on how to get that in and weld that. And then this apparatus is all welded on here, fillet weld all around. It's cleaned up, and we're going to rattle can this one here in a little bit. But when you come over here, it's going to fit down inside there like that. So hopefully that'll make that all easily understood if there was any questions. As you can see, that's a stupid crank plate. Well, not so difficult to understand. It is terribly awkward to ship. all the bolts sticking out everywhere. So I have to make a wooden box to ship it. If you prefer to do the welding yourself, I ship the crank plate, piece of pipe, crank circle, and a piece of DOM, and then you can pick up your bolts at your local store. And I think that's really what you was asking for, and that kind of prefer that. I give a little lower price. I prefer that, just a whole lot easier to ship. And I have to build a custom wooden box to ship the whole crank plate.